Most network attacks don't come from the outside. They walk right in through an unsecured switch port. Welcome to Stage 2, Lesson 15, where we're going to harden the access edge using two of the most effective Layer 2 defenses available, port security and DHCP snooping. Together, they form your first real line of defense against insider threats and rogue devices. Here's the roadmap for our journey. We'll start with port security, controlling exactly which MAC addresses are allowed to speak on a given port. Then we'll layer in DHCP snooping to shut down rogue DHCP servers before they hand out poisoned addresses. From there, dynamic ARP inspection steps in to stop ARP spoofing in its tracks. And finally, IP Source Guard closes the loop by blocking IP address spoofing. 4 features, 1 hardened access edge. Before we build those defenses, let's look at what we're actually up against. The uncomfortable truth is that most Layer 2 attacks originate from inside the network. A disgruntled employee, a compromised laptop, anyone with access to a switch port. MAC flooding turns your switch into a dumb hub. A rogue DHCP server quietly hands out poison gateways. ARP spoofing redirects traffic mid-conversation, and IP spoofing lets attackers wear someone else's identity. Each of these has a well-known tool, and conveniently, each one maps directly to one of the 4 features we're about to deploy. First up, our answer to MAC flooding, port security. The idea is simple. We tell the switch exactly how many MAC addresses are allowed on a given port and optionally which ones. With sticky learning, the first MAC seen on phase 05 gets locked in and anything else trying to talk gets shut down. Now, when a violation happens, you've got 3 flavors of response. Shutdown is Cisco's default. The port goes error disabled and waits for a human. Restrict drops the bad traffic but keeps the port alive and logs the event. Protect does the same thing silently, which honestly you almost never want. No logs means no forensics. Let's put that theory into actual config. On phase 05, we first force the port into access mode. Port security won't apply to dynamic or trunk ports. Then we enable port security, cap the maximum at 1 MAC, and turn on sticky learning so the switch remembers whoever shows up first. Finally, we set violation to restrict, alive but logged, and verify with show port security interface. If you see enabled max 1 and 0 violations, you're locked in. With the port itself locked down, we shift focus to a Layer 2 service attackers love to abuse, DHCP. The defense is DHCP snooping, and the idea is beautifully simple. Only ports you explicitly trust are allowed to send DHCP server replies, like offer and ACK. Your real DHCP server sits behind a trusted uplink, while every access port, where users and attackers live, stays untrusted. So, when a rogue DHCP server tries to hand out poison leases, the switch drops those packets on site. The attack fails before a single client is fooled. But blocking rogue servers is only half the story. As legitimate DHCP traffic flows through the switch, snooping quietly records every successful lease into this binding table, pairing each MAC with its assigned IP, the lease time, the VLAN, and the exact switch port it came in on. You can pull it up anytime with show IP DHCP snooping binding. And here's why this table is gold. It's the ground truth for who's really who on your network. Dynamic ARP inspection leans on it to validate ARP replies. An IP Source Guard uses it to filter packets at the port. Without this table, none of the defenses we're about to cover would have anything to trust. And the first of those defenses is dynamic ARP inspection. Picture this. An attacker on 1099 starts shouting unsolicited ARP replies, claiming to be the gateway at 10.1. Without DII, the victim believes it, and every packet bound for the internet gets funneled through the attacker. Classic man in the middle. DAI stops this cold by cross-checking every ARP message against the snooping binding table. The IP says 10.1, but the table says 10.1 lives on GDSud Dora 1, not .9. Mismatch. Drop the frame, log it, optionally error disable the port. 1 line of config per VLAN, trust your uplinks, and ARP poisoning is off the menu. Now we tighten the screws further with IP source guard. Where DAI watched ARP, source guard polices the actual data packets. Every frame leaving a port must carry a source IP that matches what DHCP handed out for that port. So a host that legitimately got 10.5 on phase 01 sails through. But if someone manually sets their IP to 1099 and tries to send traffic from that same port, the binding table doesn't agree, and the switch drops it on the spot. One command, IP verify source, under the interface, and as long as DHCP snooping is already running, IP spoofing from inside your network is finished. Step back for a moment and look at what we've built. Port security gives us a stable MAC-to-port mapping and stops MAC flooding cold. DHCP snooping layers on top, blocking rogue servers and producing that critical binding table. Dynamic ARP inspection consumes that table to validate every ARP and shut down spoofing. And finally, IP source guard uses the same bindings to lock each port to its rightful source IP. 4 features, 1 chain, and notice how each one feeds the next. But all of those features still answer the question, what is connecting? A MAC, an IP, a binding. 802.x raises the bar and asks, who is connecting? The port boots in an unauthorized state, passing nothing but EAP. When a laptop plugs in, the switch acts as a middleman, relaying credentials to a Radius server, which checks them against Active Directory. Accept, and the port opens, often into a specific VLAN. Reject, and it stays sealed. This is identity-based access, right at the edge. So let's pull the whole story together. Port security caps how many MACs a port will tolerate, with sticky learning making that list permanent and shut down as the default response. DHCP snooping splits your ports into trusted and untrusted, ensuring only legitimate servers hand out leases. And the binding table it builds becomes the source of truth for both dynamic ARP inspection and IP source guard. DI then shuts down ARP spoofing by cross-checking every reply against that table. And remember the principle underneath it all. Layer the defenses. Each feature reinforces the next. With 800 and it's capping the stack by answering who, not just what. Here's your cheat sheet. Keep this one handy. Port security with sticky MAC and a shutdown violation mode is your baseline. 1 MAC for user ports, 2 when there's a phone behind a PC. DHCP snooping builds the binding table that powers DI and IP source guard, and 802.1x with Radius sits on top as the strongest control. Remember the order of the defense stack: port security, DHCP snooping, DAI, IP source guard, then 802.1x. That's your hardened access edge. And that wraps up our deep dive into Layer 2 access edge security. Up next in Lesson 16, we shift gears from protection to performance, quality of service, and voice VLANs, where you'll learn how to prioritize the traffic that actually matters: VoIP calls, video streams, and your critical business apps. Catch the full series on Dargslan.com or over on YouTube at Dargslan. I'll see you in the next lesson.